Good morning to all. Welcome to Anu Krishna online chemistry classes. And today we'll discuss about the SI base units and symbols and their definitions. Okay. And already in the previous class we have discussed about the few fundamental quantities and their SI units and then symbols. There is a total 7 fundamental quantities are there: length, mass, time, amount of substance, electric current, unit of thermodynamic temperature, and then finally last one is a luminous intensity. Out of these 7 fundamental quantities, the 4 quantities are explained: length, mass, time, amount of substance. And today I will discuss about the remaining fundamental quantities: electric current, unit of thermodynamic temperature, and the finally last one is a luminous intensity. Okay, now in these three, first one is electric current. Electric current. Then what about the symbol of the electric current? What about the symbol of the electric current? The electric current can be represented by the symbol capital I. Capital I. And what about the SI unit of electric current? The SI unit of electric current is Ampere. The SI unit of electric current is Ampere. Okay. It can be represented by the capital I, and SI unit is Ampere. SI unit is Ampere. Then what about the symbol of the Ampere? A. The symbol of the Ampere is A. Okay. Then first of all, how to define the Ampere? How to define the Ampere? Ampere is defined as a constant current. The constant current which, if maintained two straight parallel conductors, and their length is infinite length, and negligible circular cross-sectional area, and they are separated by a 1 meter distance. And between these two conductors, certain force is developed. How much force is developed means 2 into 10 power minus 7 Newton per meter of length. 2 into 10 power minus 7 Newton per meter of length. This amount of force is developed. Then it is called as an Ampere definition. Okay. How to define the Ampere? The constant current which, if it is maintained two straight parallel conductors of infinite length, of negligible cross-sectional area, and the two parallel conductors are separated by the 1 meter distance. And between the two parallel conductors, certain force is produced which is equal to the 2 into 10 power minus 7 Newton per meter of length. It is only known as Ampere. Ampere. Okay. Next, after the electric current, one more thing is a unit of thermodynamic temperature. Unit of thermodynamic temperature. Okay. First of all, what is the unit of thermodynamic temperature? The thermodynamic temperature can be represented as a capital T. The thermodynamic temperature which can be represented as a capital T. Then what about the SI unit of thermodynamic temperature? Kelvin. Kelvin is the SI unit of thermodynamic temperature. Okay, now it can be represented as capital T. Then what about the units? Kelvin. Kelvin is the SI unit of thermodynamic temperature. Then what about the symbol of Kelvin? Capital K. Okay, now. Then what about the definition of Kelvin? A Kelvin is the unit of thermodynamic temperature. The fraction of 1 by 273.15 thermodynamic temperature of triple point of water. The fraction of 1 by 273.15. It is a thermodynamic temperature and it can be exist triple point of water. Triple point of water. Triple point of water is nothing but at which temperature the three phases of water coexistence takes place. The coexistence of water takes place at a particular temperature. Okay now. It is a fraction of 1 by 273.15. Then it is called as a Kelvin. It is called as a Kelvin. Okay now. Next, the last one is a luminous intensity. Luminous intensity. First of all, what is the representation of luminous intensity? The luminous intensity can be represented by the IV. It can be denoted by IV. IV. Then what about the units of luminous intensity? What about the units of luminous intensity? The SI unit of luminous intensity is candela. The SI unit of luminous intensity is candela. Then what about the symbol of the candela? CD. CD is the SI unit symbol of candela. CD. Okay now. Then what about the definition of candela? What about the definition of candela? A candela is a luminous intensity in a given direction. Candela is a luminous intensity in a given direction and which can produce the monochromatic radiation. Which can produce the monochromatic radiation. The frequency of that radiation is 540 into 10 power 12 hertz. 540 into 10 power 12 hertz. And that radiant intensity in that same direction 1 by 683 watts per steradian. Okay. So candela is defined as it is a luminous intensity in a given direction which can emit the monochromatic radiation of frequency 540 into 10 power 12 hertz and that radiant intensity in the same direction 1 by 683 watts per steradian. This is the definition of the candela. Okay, now here steradian is the unit of solid angle. Steradian is the unit of solid angle and watts per steradian. This is the unit of radiant intensity. Okay, now what about the frequency? 540 into 10 power 12 hertz. Monochromatic radiation is nothing but single color. Single. Okay, now only one color is radiated. Then what about the frequency of that monochromatic radiation? 540 into 10 power 12 hertz. Okay, now how much it is emitted? 1 by 683 watts per steradian. Watts per steradian is the unit of radiant intensity and the steradian is the unit of solid angle. Okay, so these are the remaining three definitions, SI units and their respective symbols. Okay, next we can use some of the prefixes in SI units while representing the distance in the form of multiples or submultiples. Okay, now the multiples and the submultiples, their prefixes in SI units. multiple. Okay. Next, prefixes used in the SI system, and what about the symbols? For example, the multiple prefix and symbol. We can take it 10 power minus 18, 10 power minus 18, and it is a prefix auto, and the symbol is A, and 10 power minus 15 femto, and F. Femto is also known as a Fermi. 10 power minus 18 auto A, 10 power minus 15 femto F, and 10 power minus 12 pico. Okay, now multiple 10 power minus 18 meters, 10 power minus 12 meters, 10 power minus 12 meters. Here pico, then symbol is P. Next 10 power minus 9, then the prefix is nano, then the symbol is N. 10 power minus 6 micro, then symbol mu. 10 power minus 3 milli, then 10 power minus 12 centi C, or 10 power minus 1 deci, and D. Okay. Next, 10 deca dA, 10 deca dA, 10 square hecto H. Next 10 cube kilo K, kilo K. Next 10 power 6 mega M. Next 10 power 9 giga capital G. 10 power 12 tera capital T. 10 power 15 peta P. 10 power 18 exa E. Okay, so these are the multiples, prefix, and the symbols. Here majorly multiple prefix symbol. Multiple prefix symbol. 10 power minus 18 auto A, 10 power minus 15 femto F. Okay, 10 power minus 15 minus 12 minus 9 minus 6 minus 3 minus 2 minus 1. 10 power minus 1 are 10, 10 square, 10 cube, 10 power 6, 10 power 9, 10 power 12, 10 power 15, 10 power 18. Respective prefixes and respective symbols. థ్యాంక్ యూ స్టూడెంట్స్. ఈ వీడియో కనుక మీకు నచ్చినట్లయితే సబ్స్క్రైబ్ చేయండి, షేర్ చేయండి, లైక్ చేయండి.